It is an interesting section indeed, because it is about absolute convergence. We will see together, inshallah, what we mean by absolute convergence. You will be able to know that after finishing this. And also we have conditional convergence. We have two new tests that we have in this section to test the convergence, especially the absolute convergence. At the end, we will mention that rearrangement of any the terms of infinite series does not affect the absolute convergence. We need to recall, Shabab, together what we have achieved so far, from the beginning to so far, up to now. Indeed, if you remember, we have started with 11.1. In 11.1, we have studied sequences. So there, it is about just the limits. Take the limit. If the limit exists, the sequence converges. Otherwise, it diverges. Starting from 11.2, we have studied the series. So we have studied 11.2, 11.3, 11.4, 11.5. All of these sections were about series. Here we have defined the definition, the main theorem of convergence, and also the geometric series, the telescoping series, the harmonic series. In 11.3, we have studied the integral test. In 11.4, the comparison tests. In 11.5, the alternating series test. In all of these sections, Shabab, we assumed that the nth terms are positive. So we say that when you apply the comparison tests or the integral test, the nth term or the terms must be positive. We cannot apply those tests for series with negative terms. But in 11.5, we mentioned that we can deal with such series if it is alternating, not necessarily positive. If it is alternating positive, negative, positive, negative, positive, negative, we can apply the alternating series test. And you remember that test, when it decreases to 0, then it is convergent. Today, in 11.6, we will be allowed to deal with any series, not necessarily with positive terms. It could be positive, it could be negative, it could be alternating, it could be anything. And this will make, of course, make this much easier and cover most of the types of series. So let's start with defining the absolute convergence. What we mean when we say that a series is absolutely convergent. So a series, any series, is called absolutely convergent if the series of the absolute values is convergent. Simply, you have a series, you want to know if it is convergent or not. Look at the series of the absolute, look at the series of the absolute values. So look at the series of the absolute value of the nth term. If this is convergent, if it is convergent, then this one is absolutely convergent. So what is the absolute convergent series? It is the series that its absolute value series is convergent. طبعا if the terms are all positive, if it is with positive terms, the absolute value will be the same as the nth term, and in this case the absolute convergence is the same as the convergence, so no need to talk about that here. So they are identical. Let's take an example, Shabab. This one, it is alternating, by the way, because we have here -1 to the power n minus 1. It is alternating. So you can use 11.5, the alternating series test. Who remember, Shabab, by the alternating series test, is this convergent or divergent? This is convergent, Shabab, if you remember. It is convergent because it decreased to 0, the nth term. Now, the question is it absolutely convergent? To know if it is absolutely convergent or not, what you can do, just look at the series of the absolute value. And the series of the absolute value terms is the absolute value. What is the absolute value of -1 to the power n, Shabab? N minus 1 or n plus 1 or whatever, it is always 1. Because this is just positive or -1, and the absolute value of 1 is 1, the absolute value of -1 is 1. So no need The absolute value of negative 1 to the power n minus 1 is 1 over the absolute value of n squared. It is n squared because it is positive. So now, is this series? This is the series of the absolute value. This is the series of the absolute value. Is it convergent?
No, it's divergent.
This is not convergent?
This
Yes.
convergent.
Yeah, Shabab, this is a P series. It is convergent. It is a convergent P series with P equals to 2, greater than 1. So it is convergent P series. Okay, so it is convergent. So now the series of the absolute values, is convergent. So what? So the original one
Absolutely convergent.
is absolutely convergent. Absolutely convergent. Okay, let's take another example. This one. Yes, please.
Is there a difference between absolutely convergent and conversion?
We will see that in a minute. Just a minute. We will see the relationship between convergence and the absolute convergence and which one is stronger. What do you think? Which one is stronger according to your question?
I think absolutely convergent.
Yes, you're right. You're right. Let's see this now, ya Shabab. This one, ya Shabab, if you remember, it is convergent also. By the alternating series test, this is convergent as it is. Okay? The question is it absolutely convergent? If you take the absolute value, Shabab, the absolute value of negative 1 to the power n minus 1 is 1. The absolute value of n is n because n starts from 1. So is this convergent or divergent?
Divergent.
This is divergent. What is this, ya Shabab? This is the series of the absolute value. So now, is this one absolutely convergent? Is it absolutely convergent?
No.
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 Because the series of the absolute value is not convergent. So this is not absolutely convergent. So it is convergent. If you look at it, it is convergent, but not absolutely. Not absolutely. Why it is not absolutely convergent? Because the series of the absolute values is not convergent. Okay? So what we call such type of this one, if you have a series that is convergent but not absolutely convergent, we call it conditionally convergent. A series is called conditionally convergent if it is convergent but not absolutely convergent. What is the best example about this is the alternating harmonic series. This is called the alternating harmonic series. This is the harmonic series, of course, without negative. And example 2 shows that the alternating harmonic series is conditionally convergent. This means, ya Shabab, that it is possible for a series to be convergent but not absolutely convergent. So let's ask this question now. Now, convergent. If it is convergent, does it imply absolutely convergent? If it is convergent, is this means that it is absolutely convergent? I'm asking now. What
No.
about absolutely? If it is absolutely convergent, does it mean that it is convergent?
Yes.
Yes.
So this is wrong. This is no, and this is yes. This is what you are saying.
Yes.
Yes.
We have an example for this. We have a series that is convergent but not absolutely convergent. So you are right. This is not true. So the convergence does not apply, does not imply absolute convergence. But if it is absolutely convergent, it is convergent. So this is true. The absolute convergence implies the convergence, and we have here a theorem about that. This theorem says if the series is absolutely convergent, then it is convergent. So it is like a spatial over, ya Shabab. It is a spatial over. If you have the absolute convergence, you will have the convergence for free. Okay? It is enough to be absolutely convergent. But the opposite, the converse, is not true. You can have this theorem in two different forms, in three different forms. This is one way. The another way is this, and this is what I'd like as a mathematician. If the series of the absolute value of an converges, and this is of course is the same, this is equivalent to say absolutely convergent. This is the meaning of absolutely convergent. Then the series converges. This is interesting, ya shabab. If the sigma of the absolute value converges, then the sigma without absolute value converges. Okay? Or you can, of course, I'm sure that you prefer this one. Every absolutely convergent series is convergent, but not the opposite. Not every convergent is absolutely convergent. If you want to remember an example about that, just remember the alternating harmonic. It is convergent, but not absolutely convergent. Determine whether this series is convergent or divergent. What do you think, guys, about this one? Is it convergent or divergent? And how to decide about that? Which way you will use? Let me ask you a question at the beginning. Is it alternating? Can we use the ideas of 11.5?
No,
Yes, it's not.
no.
Yes, it's.
Why you didn't agree? Is it? It is or not? It is.
No.
It is alternating or it is not alternating. It cannot be both.
It's not
No,
alternating.
it's not alternative.
If you
No,
are saying for
it should
those
buy.
who are saying that it is alternating, what does that mean? What do you mean by alternating? It is -1 to the power n or n minus 1 or n plus 1, whatever. So it is -1 to the power n multiplied by a positive number. So it will keep doing this: positive, negative, positive, negative, positive, negative, and so on. So if you remember the graph of cosine, this is pi over 2, this is 3 pi over 2, this is pi. 1 is here, 2 will be here, I think. 3 will be here. I'm not sure about the calculations, but whatever, it is not 1. Cosine n will be positive or -1 only at what? Cosine what? Cosine theta equals positive or -1, ya shabab. If theta is what? If theta is n
Zero.
bar, if it is 0, 0, by 2 by 3 by 4, and so on. This is n, no by. So you cannot guarantee the alternating process. So it might be negative, 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 then positive, 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 then negative, then positive, then. So it is not alternating. It is not alternating. So you cannot use the alternating series test. In this case, you need to think about what? About the absolute convergence. You can think about if you want to see if it is convergent or divergent. This is a nice trick, by the way, Shabab. Think about the absolute value of the nth terms. If you can do something about it, good. If you cannot, you can think about other tests. So now if you distribute the absolute value, this will be the absolute value of cosine n. Cosine n, it could be positive, it could be negative. We cannot remove the absolute value. The absolute value of n squared, it is n squared because it is positive. Now this series, ya shabab, is convergent or divergent, and how to show that? Any idea? Now this is positive, ya shabab. We can use the previous test that we have studied before. Anyone other than Walid, ya shabab? Thank you, Walid. I will ask the other Mansour.
Yeah, I think I will compare it with 1 over n squared. It's less than 1 over n squared.
Is it the same idea, Walid, or you have another one?
No, it's same idea.
Okay, thank you both, Mansour and Walid. So guys, you know that the absolute value of cosine n is less than or equals 1. So if you divide both sides by n squared, then clearly that this series, the series of p series with p equals to 2, this one is convergent. You know that. So this implies that this one also convergent. Why? By the comparison test. It is less than a convergent one. When it is less than a convergent one, then it is convergent. When it is greater than a divergent one, it is divergent. But for other cases, no conclusion. If it is greater than convergent, we don't know. If it is less than a divergent, we don't know. So this is clearly less than a convergent, then it is convergent. So this one, ya shabab, is what? Convergent. By what? By the comparison test, or the direct, because we have two tests, by the direct comparison test. Okay? So the series of the absolute values is convergent. So what? So what?
Absolutely,
What is the decision about this one?
absolutely.
Absolutely convergent.
Absolutely convergent, because it's the series of the absolute value is convergent. Great, guys. So here we are. Let's take another. This is a solved exercise. I'll leave it for you, Shabab. Again, you will take the absolute value. When you take the absolute value, you will forget about this. So if you take the series of the absolute values, you will have this one, and this one is convergent. So this one is absolutely convergent. Let's come to the P series. You remember, Shabab, the P series and the alternating P series. We solved this exercise yesterday in the recitation of 11.5. Please remember that. Go to the recitation and check that. We have studied this yesterday. Who can remind me, Shabab, if you still remember what we did yesterday about this?
It's greater than 0, it's
Divergent if what?
less than 0.
If B less than or equal.
Yes.
By which test? By the test for divergence, Shabab. Just take the limit of the nth term, with negative 1 to the power n minus 1, the whole one. The limit of negative 1 to the power n minus 1 over n to the power b, it does not exist, or infinity, if when n goes to infinity, if b is less than or equal 0. Check that. Okay? And it converges if b is if what? If
Get
b is
on.
greater than 0. So this is why he mentioned here this. So the alternating series test, when p is greater than 0, it converges. Is that right? It is alternating as an alternating. It converges by which test, ya shabab? By the alternating series test. Okay? Now the question is it when it is absolutely convergent? Now we know that it is convergent if b greater than 0. Now what you will do, you will think about the series of the absolute value. What is the series of the absolute value, Shabab? The series of the absolute value is what? When you take the absolute value, this will be 1 over n to the power b. What is this?
Normal
This is
B.
the series.
Normal.
This is the B series. This one is convergent if what?
Greater than 1.
It diverges if P is less than or equals 1, converge if P greater than 1. So according to this, here we have P greater than 0. So here we have, when B is greater than 0, we have two cases. It is greater than 0, P is greater than 0, but less than or equals 1, or it is greater than 1. So if it is between 0 and 1, what we will have? And if it is greater than 1, what we have? I'm talking about this one now. About this one, Ishabab.
Not absolutely, the first one.
Here, the first one, it is convergent, but not absolutely. So what is it? What we call it?
Conditionally.
Conditionally, it is conditionally convergent. And here, if B is greater than 1, its absolute value, the series of the absolute value is convergent. So here it will be what? Absolutely convergent. So to summarize, ya shabab, the alternating B series is absolutely convergent if B greater than 1, conditionally convergent if P greater than 0, less than or equals 1, divergent if B is less than or equal 0. Clear? Let's now go to another, to the ratio test. In fact, the first test for absolute convergence. We have two tests for absolute convergence. The first one is the ratio test. If you have a series that is not necessarily with positive terms, it could be negative terms, no problem. It could be alternating, no problem. So if you have a series an, you can decide about if it is absolutely convergent and therefore convergent or divergent. How? Just take the limit of the absolute value of the ratio between an plus 1 and an. So you are just replace the nth term n by n plus 1. You will get a number. You will get a number. If this number L is less than 1, then the series is absolutely convergent and of course convergent. If this number, if this limit is greater than 1 or infinity, then the series is divergent. If the limit is 1, the test is inconclusive. There is no conclusion, no conclusion. The test fails to decide about the convergence and divergence. It might converge, it might diverge. Let me give you an example about this case, the last case. For instance, take this one. Convergent or divergent, ya shabab? This is convergent. We know that. It is a convergent series. It is B series. What is that? It is a convergent one. Now look at the limit of the ratio between an plus 1 and an. This is an. This is an plus 1. If you take the ratio, shabab, don't do this. I advise you always to write an plus 1. This is an plus 1 multiplied by the reciprocal directly. So you will get this step immediately. Now, what you have here? Again, I don't see the point here. I think what you can do here, shabab, is this: n over n plus 1 all squared instead of this step. And this is clearly when you get the limit inside, it will be limit n over n plus 1 all to the power 2, because it is a continuous function x squared. Now the limit here is 1, so it is 1 squared, it is 1. So the limit here goes to 1. Okay, and it is convergent. Look, it is convergent, and the limit is 1. I don't know why the pen is not working properly. Now, let's take another example. Let's take another example. This one. This one is divergent. But again, the limit, if you take the ratio between the nth term and nth plus 1, you will get 1 also. The limit is 1. So here, when the limit is 1, it might be divergent, it might be convergent. So this is why the test gave no information about the convergence and divergence. The series might converge, might diverge. So go to another test if you have if the limit is 1. Now let me summarize this for you in a short way. So the ratio test says what? If the limit of the ratio is equals to L, if this L is less than 1, then it is absolutely convergent and therefore convergent. If it is greater than 1 or infinity, it is divergent. If it is 1, no conclusion. The test fails. Example, test this series for convergence, for absolute convergence. Now this is an, ya shabab. This is an. Now what you will do, you will find the absolute value of an plus 1 over an. What is this equals to? The absolute value, shabab, of negative 1 to the power n or n minus 1 or whatever, it is always 1. So what you can do, you can ignore it. So you can write it here, no problem, but for the first time, let's do that. So now we will do an plus 1. So this is the same, but we will replace n by n plus 1. N plus 1 to the power 3 over 3 to the power n plus 1 times it is divided by an, but we will multiply by the reciprocal to save one step. So here we will multiply by the reciprocal, 3 to the power n. Here we will have negative 1 to the power, or you can keep it up, no problem, n to the power 3. Don't waste your time, ya shabab, calculating this with this, because the absolute value of this is what? 1. The absolute value of this is 1. So I advise you to if it is just a matter of a product, just to ignore it. So what we will have in the next step, the absolute value of this one is 1. The absolute value of this one is 1, gone. Now, this is positive, this is positive, this is positive, this is positive, because n starts from 1, so no need for the absolute value anymore. So what we have here, shabab, we have n plus 1 to the power 3 over 3 to the power n times 3. Why I did that? Because I need to cancel it with this one. Times 3 to the power n over n to the power 3. Now this will be cancelled with this. And this over this, you can write it as 1 over 3. So you have here 1 over this 3 times this over this will be what? Will be n plus 1 over n all to the power 3. Now, when n goes to infinity, this goes to what? To third. This is a constant, the limit. And the limit here, shabab, is n over n is 1, 1 over 1. It is 1 to the power 3, so it is 1. This equals to third, and this third is less than 1. Again, ya shabab, when I say L is less than 1, it doesn't mean that it is negative. It cannot be negative, because L, ya shabab, here is the limit of absolute value. The absolute value is greater than or equal 0. It cannot be negative. If you get a negative number here, make sure you did a mistake. But you can have 0. So when we say L less than 1, we mean greater than or equal 0 also. It could be, but it cannot be negative, never ever. So what is the decision here, ya shabab? So this one is what?
Absolutely convergent.
By which test? By the ratio test. It is absolutely convergent using the ratio test. Let's take another example. Here, notice that the nth term is positive. It is not alternating, not negative. N to the power n is positive when n starts from 1. Also the factorial. So no need for the absolute value. So when you calculate an plus 1 over an, what you will do? This is an plus 1. Replace n by n plus 1. Divided or multiplied by the reciprocal of an. Now, ya shabab, as I told you before, n plus 1 factorial, it is just n plus 1 multiplied by n minus 1 multiplied by n minus 2 up to 3 to 1. So all of this, indeed, it is n factorial. So you will write n plus 1 times n factorial. Here, this one, write it as n plus 1 to the power n multiplied by n plus 1 to the power 1. Now you will cancel this with this, and you will cancel the factorial with the factorial. You left up with what? You left up with n plus 1 over n all to the power n. What is this, guys? This goes to what? What is the limit of this when n goes to infinity? What is the limit of this when n goes to infinity?
Infinity.
This goes to what when n goes to infinity? In other words, what is the limit of this?
E.
Infinity.
Infinity.
E.
E.
Yes.
Isn't it
I.e., do you mean yes?
intermediate value?
Yes. Shabab.
E
No,
means
E.
2.7.
2.7.
I'm kidding. I know. So this is n over n is 1 plus 1 over n all to the power n. I think now you remember that it is E. In 11.1, ya shabab, in Math 101 and also in 11.1, I mentioned this for you, that this, when n goes to infinity, is just equals to e to the power x. So this one, it is e to the power 1. So this is equals to e, which is less than 1 or greater than 1?
Of course, great.
Of course, greater than 1. So what is the conclusion about this series?
It is
This
divergent.
is divergent. It is divergent. By which test? By the ratio test. It is divergent. By the way, you were able to show that this one is divergent by using the test for divergence. You know that n to the power n over n factorial, it is greater than or equals n for any n greater than 1. Check that. Of course, for 1, it is the same, but after that, it will be greater. Now, this one goes to where? To infinity. But for sure, also, this will not, never, ever, cannot approach 0. It will not approach 0. It will go to infinity also. So you can use also the test for divergence, but it's okay. Also, the ratio test helps. And this is a solved exercise for you, Shabab, to practice. Look here, Shabab. It is, of course, very convenient to use the ratio test whenever you have factorials, unless طبعا the limit is 1. In some situations, the limit could be 1. So when you have factorials in factorial, use or think about using the ratio test. For this one, who can tell me what is the best test to use to decide about the convergence and divergence of this series? طبعا we can use the ratio test يا شباب, and we will use it, by the way. Look, he used the ratio test. He find what is an plus 1 over an, no absolute value because all are positive, by the way. Now by the ratio test, look what you have. This is what you have by the ratio test. Less than 1, so it is convergent. By the way, يا شباب, be careful. This is not the sum. This is not the sum. The ratio test and the root test does not give you the sum. But for this one, for this specific one, we can find the sum. But it is not 2 over 3. How to find the sum of this one, ya shabab?
This is a geometric series.
It is not a geometric series. It is a sum of 2 convergent geometric series. Be careful. So it is not in this form as it is not. So what you can do, you can just write it as a sum of 2 to the power n over 3 to the power n, which is 2 over 3 to the power n, plus 5 over 2 to the power 3. 5 can go out, and here you have sigma 2 over 3 to the power n. This is geometric series, and this is 5 out. Sigma n starts from 0 to infinity for 1 over 3 all to the power n. Now this is geometric, and this is a over 1 minus r plus this is a over 1 plus minus r for that one. And this is the sum, 21 over 1. So if you have a test, that can tell you about the convergence and give you the sum, use it. It is much better the test that will only give you the convergence without having the sum. So it was easier here to use, ya shabab, the geometric series idea. Again, here, ya shabab, you will use the ratio test. When you have factorial, use the ratio test. Please, ya shabab, practice by solving this by yourself. The test here fails, look at here, it is fails. And in this case, we cannot use the ratio test. We should find another test that we don't have so far. Now, we have another test, by the way. If you have a special type of series, the ratio test, as I said, it is very convenient when you have factorials. But when you have powers of n, when you have something to the power n, sometimes it works like what we did before, but also in some cases the ratio test doesn't work, and in that case you can use, of course, the root test, or as some textbook call it the nth root test. So this test is very convenient when you have nth powers. What does it say? It is the same as the ratio test. Just if you have a series. What you will do, you will take the absolute value of the nth term, then you will take the nth root of this term, which is the same as the power 1 over n. Then take the limit. If the limit equals to a number less than 1, then the series is absolutely convergent and therefore convergent. If the limit is greater than 1 or infinity, then it is divergent. If it is 1, unfortunately, the root test also is inconclusive, which means that no conclusion, no information. By the way, let me ask you a question. What about if the test is if the root test fails when the limit is 1? Can I go and use the ratio test, ya shabab? What do you think? If the limit here is 1, can I go? So I cannot use the root test. Can I go and use the ratio test? Or
No.
think about it? Don't waste your time doing this. I add a remark here. If L is 1 in the root test or in the ratio test, don't try the another one, because again it will be 1 also. So if it is 1, think about a test other than these 2 tests. Again, this is the summary of the root test. By the same way, I will combine them together at the end. Let's take an example here. So look, here we have a power. So what you will do, you will take now the absolute value. By the way, this is positive, no need for the absolute value. So you will just take the nth root. The nth root of this nth term will be, this will be all to the power 1 over n. So this will be cancelled with this, and you will have 2n. And this goes to what, ya shabab, when n goes to infinity? When n goes to infinity, this goes to
2 over 3.
2 over 3, clearly 2 over 3. So which is less than 1. So this series is convergent, absolutely convergent. By which test? By the root test. Here, look, you have powers, you have powers, you have powers. Think about the root test. By the way, for some of them, you can also use the ratio. It might work, but not always. Remember here, shabab, this is interesting. What is the limit of the nth root of n? When you use the root test, usually you have something like this. And I mentioned this in 11.1. It is equals to 1. You can show it, of course. And this for you, shabab, to practice, please. And this is an interesting one. We have here a series an with, this is the nth term. This is the nth term of this series. What is it? It is n over 2 to the power n if n is odd. And it is 1 over 2 to the power n if n is even. Now you will think about, let's decide about the convergence by using the root test. The absolute value, this is positive, no problem. Take the nth root. When you take the nth root, what you will have here? You will have the nth root of n. The nth root of 2 to the power n will be 2. The nth root of 1 will be 1. The nth root of 2 to the power n will be 2. Now this goes to what, ya shabab? This, the limit, what is the limit of this when n goes to infinity? Of course, a half is a constant. What about this? Also, this, the limit of this is 1. So this one, the limit of this, the limit of the nth root goes to, the limit is a half. You can show it also by the squeeze. I think he did show it by the squeeze theorem. So this means that it is less than 1. So it is absolutely convergent by what? It is absolutely convergent by the root test. The last part of this section, shabab, is about rearranging the terms of a convergent, absolutely convergent series. When you have a plus 1 plus a2, a3, a4, 5, 6, and so on, if you rearrange this, the terms, like here, for example, a1 plus a2 plus a5, then a3, a4 plus a15, then a6. This, of course, the new, if this is absolutely convergent, this also will be absolutely convergent. Okay, so if you have a series that converge absolutely, and you have another series that is just a rearrangement of the series of the previous series, then it also converge absolutely. These are the suggested problems. Tomorrow, inshallah, or after tomorrow, we will solve the recitation. I will decide about that later. This is the summary يا شباب. الزبدة إنه أنت محتاج هنا تعرف إيش نقصد ب absolutely convergent, conditionally convergent. That if every absolutely convergent is convergent, but not the opposite. And I combined here the two tests for you, the ratio and the root together. It is just about here find the ratio and here find the nth root. If the limit is less than 1, then the series is absolutely convergent. If it is 1, or طبعا here again, if we confirm that here by L less than 1, we mean L less than 1 greater than or equal 0, not less than forever. And of course, if it is greater than 1 or infinity, it is divergent. If it is 1, the tests, not the root test, the both tests, the both tests are inconclusive. Okay, now I will give you, shabab, 1 or 2 minutes to decide about this one, please. And I will launch a polling for you. You can vote and choose the right answer. Take a pen and paper, shabab, and start to practice, please. This series is divergent by the root test, convergent by the root test, a series for which the root test is inconclusive. Divergent by the test for divergence. Divergent by the ratio test. What do you think? I think it is reasonable to think about the root test. He mentioned it 3 times, but not because of that. Because that you have also here powers, ya shabab. I think it is, you can also use the ratio test, maybe, I'm not sure, but you can use the ratio test also as well. The ratio, I think it works. The ratio test is work also for this one. So I advise you, ya shabab, here as a hint to use the root test. Use the root test. But of course, it is better also to simplify, then apply the root test. So you can simplify it this way. This is 2 to the power n, 2 to the power -1, 3 to the power n, 3 to the power 1, all over n to the power n. Continue, Shabab, please. It is good to practice. This equals to, now you have here 2 to the power -1 and 3 to the power 1. So this is 3 over 2, get it out. So you have 3 over 2, then we will get it out. This is 3 over 2. Here 2 to the power n, 3 to the power n, it is 6 to the power n. Over n to the power n. I think now, ya shabab, it is clear what you can do. This will be equals to 3 over 2 out. 6 to the power n over 6 over n. 6 over n all to the power n. Now it is just about this one. Don't worry about the constant multiple, ya shabab. If it is convergent, the constant multiple is convergent. If it is divergent, the constant multiple is divergent. So just think about this one. So here you will think about an, which is 6 over n. You will take the absolute value, which is the same. Then you will take the nth root, which will be this to the power n. Then you will take the limit when n goes to infinity for this one, what you will have. This is to the power n. I forget the power n, all to the power 1 over n. This will give you, of course, the limit. Let me check, ya shabab. 24 students, 25, good. Let me end the polling and share with you the results. Here we are, ya shabab, most of you with choice A. 10 students with A, 9 with B, 5 with C, and 1 with D. The right answer is, let's see together what is it. Let me stop sharing and let's see. Now, as I said, ya shabab, we will find the limit when n goes to infinity for the nth term of the absolute value of the nth term, which is, of course, the limit when n goes to infinity for all to the power n. The nth term is 6 over n, all to the power n, so it will be cancelled. 6 over n, all to the power n, all to the power 1 over n. This is equals to the limit when n goes to infinity for 6 over n, which is 0, less than 1. So it is absolutely convergent by the root test. And accordingly, the right answer is B. It is convergent, not divergent. I don't know why 10 students, like 10 students or more, they say that it is divergent by the root test. Make sure, ya shabab, it is about limits. Be careful. Let's give you another chance. Yalla, solve this one, ya shabab. Let me launch a new polling. So now you have a new polling. You can, of course, solve and now it is about, is it converged absolutely or conditionally or divergent? Who can give us a hint, ya shabab, which test we may use?
Ratio.
The ratio. Why the ratio, not the root?
Factorial and factorial.
Yes, ya Ali, you are right. Because of the factorial, ya shabab. When you have factorial, don't use the root test. Use the ratio test. So good hint يا علي أحسنت. So according to the ratio test, طبعا you will take the absolute value. This will gone. So the absolute value of an plus 1 over an, come on. The absolute value of an plus 1 over an will be equals to what? N plus 1 to the power 100 multiplied by 100 to the power n plus 1. Please, Shabab, continue solving. N plus 1, 100 factorial. This is an plus 1 multiplied by the reciprocal of an. What is the reciprocal of the an? It is n factorial over n to the power 100, 100 to the power n. Now, in the next step, you will simplify. This will be n plus 1 to the power 100 times 100 to the power n times 100 over n plus 1 factorial. As I showed you before, it is n plus 1 times n factorial. And here we have n factorial over n to the power 100 times 100 to the power n. Now we have a cancellation here. This will be cancelled with this n 100 to the power n with 100 to the power n. What else can be cancelled? I think that's all. This is now equals to where we are here. So this is equals to 100. This one over this one. So it is n plus 1 all to the power 100 over n to the power 100 times 100 over n plus 1. What is this, guys? Let me see. Where are you now? Aha, it is already you have seen the answer. So it is gone. Most of you, they choose A, and it is the right answer. Let me share with you the results. It is A. But why? Why it is A? Let me check that I didn't forget anything. This is 100. This is n plus 1. That's it. Okay. Now here, ya shabab, we have what? Here we have n plus 1 over n all to the power 100 times 100 to the power n plus 1. The limit of this one is what? 100 over n plus 1 when n goes to infinity. When n goes to infinity, what we have here? We have here 0, and here we have what? Here we have 1. Is that right? So 1 times 0 is what? Is 0. 0 is less than 1, so it is convergent absolutely by the ratio test. Let me give you in the remaining 2 minutes another one. Any hint? I need a hint from any one of you, Shabab. How to decide about the convergence, the absolute convergence of this series, if it is convergent absolutely or conditionally or divergent. If you have a question like this, what should you do? What is your first step? طبعا it is natural to think about the limit. If the limit is not 0, ya shabab, if the limit is not 0, it is divergent by this. So if I were you, I will try to check this. Is it divergent by the test for divergence? Because this is the easier way. If the limit is not 0, but the limit is 0 here, clearly 1 over infinity is 0. So this is not the case. Now, if the test for divergence doesn't work, what you will think about, ya shabab? Please. Think about the series of the absolute value. If it is absolutely convergent, it is convergent. Otherwise, you will think. So what is the series of the absolute value, Shabab? It is this one, 1 over n ln n. This one, Shabab, this one is, by the way, it is convergent using alternating series test, by the alternating series test. So it is convergent by the alternating series test. Check that, please, Shabab. Now, let's see the absolute value. This one, this series, Shabab. This series is what? It is divergent by the integral test. Check that, please, Shabab. This is divergent by the integral test. Check that. So this is divergent. The series of the absolute value is divergent, and the original one is convergent. So what is the decision now? What is the final decision? It
Condition-
confers what? It
Condition.
is convergent, but not absolutely. So it is what?
Condition.
Conditionally convergent. So the right answer is B. This is all what we have for today. Thank you, Shabab. And if you have any questions, you are welcome.